this video, we see one last example based on this concept and this chapter. Here is the question then. Make sure you go through the question carefully. First, we will draw the figure. Here is our frustum. Its height h is given to us as 3 centimeters. That is, this length is 3 centimeters. The radii of two bases are given to us as 8 centimeters and 4 centimeters. It means that the radius r1 of bigger circle is equal to 8 centimeters and radius r2 of this smaller circle is equal to 4 centimeters. Do you remember the formula for its surface area? It's pi r1 squared plus pi r2 squared plus pi r1 L1 minus pi r2 L2. Do we have everything required in the formula to calculate the surface area? The answer is no. We have values of r1 and r2. We don't have the values of L1 and L2. But what are L1 and L2? If you remember from the previous video that if we attach this smaller cone with radius of its base r2 to this frustum, then L1 is the slant height of this bigger cone and L2 is the slant height of the smaller cone. H1 is the height of the bigger cone and H2 is the height of the smaller cone. Hence, we need to find the two variables L1 and L2 first. How do we find them? We will use the concept of similar triangles that we discussed in the previous video. So we get L1 over L2 is equal to R1 over R2 is equal to H1 over H2. After substituting the values for R1 and R2, we get L1 over L2 as 2 and H1 over H2 as 2. This means that L1 is equal to 2 times L2 and H1 is equal to 2 times H2. We will name these equations as equation 1 and equation 2. Do we get the required values of two variables that we were looking for? No, we still don't. Then why do we find equation 1? How can we use it? We see that it gives the relation between the variables that we want to find, that is, between L1 and L2. So if I have the value of L2, we get L1 and vice versa. So we only need to find one of our variables now. Which one among these two is easier to find? Give it a shot. We will find L2 because finding L1 is a little lengthier. How will we find it? We will use Pythagoras theorem. From the figure, we see that triangle AOB is a right-angled triangle. So AB squared is equal to AO squared plus OB squared. It will be L2 squared is equal to H2 squared plus R2 squared. We have R2 but we don't have H2. We are given the value of H as 3 centimeters, but till now we haven't used it. We know that H is equal to H1 minus H2. So H1 minus H2 is equal to 3. But from equation 2, if we substitute H1 in this, we get H2 equal to 3 centimeters. So we now have H2 and R2. We find L2 by Pythagoras theorem. So we get L2 squared is equal to 3 squared plus 4 squared. So L2 is equal to 5 centimeters. So what will L1 be now? L1 will be 2 times 5, that is equal to 10 centimeters. Finally, we have everything required to find the total surface area of our frustum. If we substitute values of R1, R2, L1 and L2 in our formula for the surface area, we will get this equation. And hence the final answer will be this. 140 times pi. Taking the value of pi as 22 over 7, we get. So the surface area of our cone is 440 square centimeters. That really was some problem, wasn't it? One more thing I want to say before we sign out is that there is also a shortcut using which we can solve problems based on frustum of a cone. But it requires us to memorize these formulae. These formulae can be derived using the concept of similar triangles and Pythagoras theorem. But ultimately, you have to memorize these formulae. And that's something we're strongly against. With this, we complete our chapter based on surface areas and volumes, and we hope you enjoyed it.